Your pod exists, but it never starts. No containers, no logs, no application running. Kubernetes accepted your deployment but refuses to run it. You keep running kubectl get pods and all you see is pending state. This is one of the most common Kubernetes production failures. And today I will show you exactly why Kubernetes refuses to schedule your pod. Hi, I'm Shivam and this is the third video of Kubernetes debugging series. Let's break scheduling into Kubernetes. Before we get started, I have one small request. If you have been finding these videos helpful, I would really appreciate you subscribing to my channel. It's a simple way to support my work and it encourages me to keep creating more contents like this. Now let's jump onto the video. In the last video, we saw containers crashing after startup, that is, crash loop back off. But today's problem happens even earlier. The application never starts because Kubernetes first needs to decide which node, and that decision is made by the scheduler. If scheduling fails, your pod stays in pending state. Let's reproduce this on my local kind cluster. As we can see, I have one control plane node and two worker nodes. I'm gonna create a pending demo.yaml file and I'm gonna paste the contents of the pod. As we can see, the kind is pod, the name of the pod is impossible pod, it is running an nginx image, and this is the most interesting part. This resource section tells Kubernetes how many resources the application needs. This request section tells the minimum guaranteed resource required by the container. So here is an important concept. Request equals scheduling requirements. The scheduler uses requests while deciding where the pod can run. Here I am requesting 100 CPU cores and 500 gigabytes of memory, which is obviously too much for my local kind cluster. No node in this cluster can satisfy this request. So let's go ahead and we will apply this file and we'll see what happens. I'm gonna save it and I'm gonna apply this file. It says our pod has been applied. Let's try to get pods. And we can see our pod is in pending state. So even after 1 minute, my pod is still stuck in pending state. Again, there was no node available on my local kind cluster which can satisfy this request. And the most important understanding here is, this is not a container issue. The container never starts. Scheduling fails before container creation. Now let's understand what Kubernetes is doing internally. So this is the flow what Kubernetes is following. So whenever we run kubectl apply command, the API server stores the pod information. Scheduler checks for the node which can satisfy the request. If no node can satisfy the requirement, the pod stays in pending state. So here the scheduler is basically matching pod requirements against node capacity. It checks CPU, memory, node labels, taints, and affinity rules. And if no node matches these criteria, the scheduling fails. Now let's try to debug this properly like a DevOps engineer. I'm gonna run kubectl describe pod command and we will scroll down to the event section. We can clearly see in the events that no nodes are available. It has insufficient CPU and insufficient memory. This is the most important debugging area. This means that my scheduler tried to place the pod, but every node rejected it. So here is an important production rule. Whenever a pod is stuck in pending state, always run kubectl describe pod command and scroll down to the event section, which will clearly tell you the exact reason of the pending state. Now let's try to fix this issue. I'm gonna update my pending demo.yaml file and instead of 500 gigabytes of CPU, I'm gonna update it to 128 MI and 100 M of CPU. Here M means milli CPU and these figures are very small compared to earlier ones. Hopefully this time our pod should get scheduled on a node and it should be in a running state. Let's try to replace our pod. It says our pod has been replaced. Let's check that. And we can see that our impossible pod is now in running state. Now, resource exhaustion is only one reason why pod can stay in pending state. in real production clusters, scheduling can fail for many other reasons. Let's try to look at another reason why a pod can stay in pending state. So I'm gonna delete this pod. Now I'm gonna edit my pending demo.yaml file. I'm gonna remove all the contents from it, and I'm gonna paste the contents of a new pod. We can clearly see the kind is pod. The name of the pod is Selector demo. It is running an Nginx image, and this is the most important part. Here, the scheduler will look for a node where GPU flag is equal to true. So let's go ahead and we will apply this file. It says our pod has been created. Let's check that. Now our pod is again stuck in pending state. Let's run this with -w option. So even after 10 seconds, our pod is still in pending state. Let's wait for some time to see if our pod gets in running state or not. So even after approximately a minute, our pod is still stuck in pending state. So like we discussed earlier, like a pro DevOps engineer, I'm gonna run kubectl describe command. And we will scroll down to the event section. And we can see it says 0 of 3 nodes are available. It has untolerated taints and 2 nodes didn't match pod node affinity selector. This means that none of the nodes on my local kind cluster has a flag GPU equals true on which our pod can be scheduled. This happens constantly in production clusters using dedicated CPU nodes. Now let's look at another advanced production failure for the pending state. Again, I'm gonna delete this pod. Our pod has been deleted. Let's check that. So we don't have any pods. I'm gonna clear the screen. Again, I'm gonna edit my pending demo.yaml file. I'm gonna remove all the contents and I'm gonna copy and paste a new pod configuration. Again, the kind is pod. The name of the pod is PVC pod. It is running an Nginx image and I have attached a PVC to it, which is persistent volume claims. Now let's go ahead. We will apply this file. It says our pod has been created. Let's check our pod. Our pod is stuck in pending state. Let's wait for some time to see if our pod comes up in running state. So even after 72 seconds, our pod is still stuck in pending state. So as we discussed earlier, like a pro DevOps engineer, I'm gonna run kubectl describe pod command and we'll look at the events. And the event says persistent volume claim broken PVC not found, which means a PVC name broken PVC does not exist on my local client cluster. Let's verify that by running command kubectl get PVC, and we can clearly see I do not have any PVC named broken PVC. So if we look at our first issue where I have provided enormous amount of resources to the pod and none of my nodes on my local kind cluster can satisfy those requirements, my scheduler rejected the pod. And when the requests were reasonable, scheduler was able to schedule the pod on a node. So here is a simple rule. Impossible requests equals pending state and valid requests equals scheduled state. So in production, pending pods happen constantly, usually because resource requests are too high or cluster is too small or wrong node selector or taints blocking scheduling and broken affinity rules. These are some of the most common use cases which can result to pods stuck in pending state. And the dangerous part is deployments may still appear successful. Your CI/CD pipeline may pass while your application never truly runs. Pending pods silently destroys availability. Pending state is not a container problem, it's a scheduling problem. Kubernetes is refusing placement because no node can satisfy the pod requirements. If the scheduler cannot find a home for your pod, your application never starts. So now you have seen what happens when Kubernetes refuses to schedule a pod. But let's say scheduling succeeds, the pod starts, the container is running, everything looks healthy, but your application still cannot work. Why? Because in distributed systems, applications needs to talk to each other, front end to back end to database, APIs to cache, and Kubernetes handle these communication using internal DNS. But what happens when DNS resolution breaks? Your pods suddenly cannot find each other. No connection, no service discovery, no communication, even though everything is running. In the next video, I will show you how Kubernetes DNS actually works, how services gets resolved internally, what core DNS does behind the scene, and how one wrong service name can completely break pod-to-pod communication. We will debug it live on my local kind cluster. That's where Kubernetes networking starts to get really interesting. I will see you in the next one. Till then, keep learning.